Hello there and welcome to Lower 6th Further Maths A-Level Pure Core 1 past paper June 2014. We're looking at question 1 here, complex numbers. Two complex numbers z1 and z2, p plus 2i and z2 is 1 minus 2i, where p is an integer. Find z1 over z2 in the form a plus bi. Give your answer in the simplest form in terms of p. Right, okay, so for this question here, for a division of complex numbers, I'd usually turn to my calculator. However, here we've got p as part of our complex number, so that's not going to be possible. So it's going to be z1, which is p plus 2i over 1 minus 2i. So what I do here is to rationalise effectively this denominator, get rid of any i's on the bottom of fractions, is I times top and bottom by complex conjugates here and here on both the top and the bottom. That way it doesn't change the complex number. So expanding the brackets, treat this as now double brackets here and here, seeing as we're multiplying top by top. So everything from the first hand bracket by everything in the second hand bracket. P times 1 is p, p times 2i is plus 2pi, 2i times 1 is plus 2i, and 2i times 2i is plus 4i squared. Okay, so this is over 1 times 1 is 1, 2i, and then the minus 2i will cancel, so it's going to be minus 4i squared. Let's simplify the I squared values now. That's minus 1, so it's going to be this is going to be a minus 4 here, so it's going to be p minus 4, add 2p plus 2 on the i's, and this is going to be divisible by I squared is minus 1, so minus 4 times minus 1 is plus 1, plus 4, so 1 plus 4 is 5. Excellent. So a part is going to be p minus 4 over 5, and that's going to add on to 2p plus 2 over 5i. Great. So that's our complex number. It's got a real part here and an imaginary part here. The next part is, given that z1 over z2 modulus is equal to 13, find the possible values of p. Right, so remembering that the modulus is a distance, we're going to have to be working with Pythagoras' theorem here. So it's a big square root of the real part squared, so p minus 4 over 5 squared, adds the imaginary part squared, 2p plus 2 over 5 squared. And the distance from the centre to this coordinate here is 13, so this is equal to 13. So now we need to solve this equation and work out the values of p. So expand the brackets yet, square root first, p minus 4 over 5 squared, add 2p plus 2 over 5 squared equals square of 13 is 169. Right, so then what I'm going to do is expand the brackets. So it would be p squared minus 8p plus 16. And on the top of the other one, it's going to be 4p squared add 8p add 4. And it's all going to be over 25, so I'm going to times by 25 on the other side, which will give me 4225. Okay, cancelling some bits out, so I'm going to get a p squared and a 4p squared, that's 5p squared. 8p and minus 8p, they will cancel, and if I take away 20 over to the other side, I will get 4205 for the other side. So now p squared is going to equal 841 by dividing through by 5. So p is therefore going to be the positive and negative of 29. The square root of 841 is 29. So P is plus or minus 29. 8 marks.